Now let us solve few examples based on the binomial expansion formula. So here we have to expand a plus 2b whole raised to 5. Uh, Let us first of all write the expansion for a plus b raised to n for our reference, since we are doing this as the first example. If you recollect, we have the binomial coefficients nc0, nc1 and so on. Then the powers of a reduce and powers of b successively increase, and so on up to the last term is ncn and b raised to power n. So therefore, if we want to write a plus 2b raised to 5, it would be 5c0 a raised to 5 plus 5c1 a raised to 4, and now the second term is 2b itself. Make sure that it's the 2b, that is the entire second term and not just b. Okay. Then moving on, we have 5c2, a becomes now a cube, and we have 2b the whole square plus 5c3 a square 2b the whole cube plus 5c4, we have just a 2b raised to 4, and lastly we have 5c5 into 2b whole raised to 5, right? So therefore that is equal to, first term is a raised to 5 because 5c0 is 1, then 5c1 is 5, so we have 5 into a raised to 4 into 2b plus 5c2 is 10 a cube, and 2b the whole square is nothing but 4b square plus 5c3 is same as 5c2 because the coefficients are symmetric, so that will be still 10 a square, and 2b the whole cube will be 8b cube plus 5c4 is 5. We have a into 2b raised to 4, so that will be 16 into b raised to 4, and lastly since 5c5 is 1, so 2b whole raised to 5 will be 32b raised to 5. And now we can write the final expression by writing the simpler terms by multiplication of individual terms. The second term becomes 5 into 2 10 a raised to 4 into b. See, as a convention we typically write all the a terms first and then the b terms within a single term, plus we have 40 a cube b square plus we have 80 a square b cube, then once again 80 a b raised to 4, and lastly 32 b raised to 5. So that's the final answer. Right. Let's solve one more problem with a different binomial. Now here we have the second term as negative. We have to expand x square minus 1 upon x whole raised to 4. Right. Now here our n is equal to 4. The first term a is equivalent to x square, and the second term we'll have to take as minus 1 upon x. Now since the second term is negative, we know in advance that the binomial expansion will have alternate positive and negative terms. Right. So firstly we have 4c0, first term is x square raised to 4, then we have 4c1 x square the whole cube into minus 1 upon x starts appearing, so which has raised to 1 anyways. Then next is 4c2 x square square and minus 1 upon x also the whole square. Then we have 4c3 x square raised to 1 and minus 1 upon x the whole cube, and lastly we have 4c4 x square has vanished and we have only minus 1 upon x raised to 4. So simplifying that further, since 4c0 and 4c4 both are 1, no need to write them. X square raised to 4 becomes x raised to 8 plus 4c1 is 4, then x square the whole cube is x raised to 6 into minus 1 upon x, so we write it as it is, plus 4c2 is equal to 6, x square the whole square is x raised to 4 into minus 1 upon x the whole square becomes plus 1 upon x square, then 4c3 is same as 4c1. We know that the coefficients are symmetric from the ends. Then x square and minus 1 upon x the whole cube is minus 1 upon x cube. And lastly, since 4c4 is 1, we have to just write minus 1 upon x whole raised to 4. So that becomes plus 1 upon x raised to 4. So therefore finally we have x raised to 8 minus 4 x raised to 5 plus 6 x square minus 4 upon x plus 1 upon x raised to 4. Alright, so that is the expansion. If you observe curiously, what is happening is the powers of x are reducing by 3 successively. So it was 8, then it became 5, then it became 2, then 2 became minus 1, which is why x went to the denominator, and that further reduced to x raised to 4 in the denominator.